Welcome to the next lecture on probability density function. In the last lecture, we have covered on probability distribution function, and now we'll continue with probability density function for both continuous and discrete random variables. So let us discuss about continuous. There's a small spelling mistake over here. Continuous, discrete and mixed types. So the random variable can be continuous random variable or a discrete random variable or a mixed random variable. So in the case of continuous random variable, fx of x is continuous. That means it's a function. So whenever I have a function f of x some 2x square plus 5y, so definitely it's a continuous function, which is an increasing or a decreasing function. And I have just made a point here, probability of x, the random variable x taking a certain value in the case of continuous random variable is always 0. I'll show you diagrammatically also. We'll discuss in the next slide. And coming to the discrete random variable, discrete is nothing but the discrete values, countable number of points if you take into existence, then I'll call it as a discrete random variable. And coming to the mixed random variable, will have a combination of discrete as well as continuous. So P is actually a discrete random variable and discrete constant you can call, and f1 of x is a continuous random variable, continuous distribution function. Similarly, this is a continuous distribution function, whereas 1 minus p will give you a discrete value. So if I take a continuous and a discrete both, then I'll call it as a mixed distribution function. Coming to the continuous and discrete, how will it actually look like? So continuous distribution function is a staircase approximation function. So it is slowly increasing, taking the value from some x1 to 1. And this is nothing but if you take the step, if you take the width of any step, that will be actually the value of the probability of xi of x actually at instant I. That means if suppose x is taking an outcome of xi, so what is the probability of x is equal to xi is nothing but this step will actually give you the probability. So it's just a discrete value. Probability is nothing but a discrete value of that instant. So in the continuous function, continuous distribution function, the probability of probability at any xi will be always equal to the width of the step. And coming to the discrete, so discrete is we already know that it is discrete points p1, p2 and so on pi. So at x1 you have a value. That's why what is the type of function this is actually called as a what type of plot it is? In MATLAB we call it as a stem plot. So in the stem plot, what is this function? This is an impulse function. So impulse function is normally used to represent the discrete values. So if I take a vector of values in MATLAB, it will give you a discrete plot like this. So it is actually stem of f of x. If I say, I'll get an impulse function. So an impulse function is treated as a discrete distribution function. So here you can see the convention. This is capital F of x is distribution, whereas small f of x is nothing but the density function. And coming to the probability density function. So normally we use the term probability density function for continuous random variables. So what is the density function? I already told you in the last lecture we have dealt with density function is equal to a derivative of the distribution function, or in other way capital F of x, that in distribution function is nothing but the integration of density function. But one thing what we have to observe is it's not from minus infinity to infinity. We already know that distribution function is always till some particular value. So it is nothing but x. If x of x is nothing but you are calculating at till x, cumulative distribution function. Integration is always averaging out. So average of all the values of x1, x is equal to x1 plus x is equal to x2 and so on till x. So that's why it is ranging from minus infinity to x. Fx of alpha, d alpha is nothing but the distribution function. So this mathematical relation is always used. If a distribution function is given, you can evaluate density. Similarly, if density function is given, you can evaluate distribution function. And this is a small example. So in the last lecture, this example already we have seen. At 0, the probability value is 1 by 4 because this is the step value. say for example 3 by 4 minus 1 by 4, which is 2 by 4. 1 by 2 is nothing but this value. Okay, so like that, this is actually a continuous function. So this is a discrete function. So discrete function, how will you represent that? This is pi. So pi multiplied with delta of x minus x1, x minus x2, and so on, x minus xi. So this is nothing but the density function. So density function is nothing but the product of the amplitude of that value with the timing, delta of x minus xi. Del is always a impulse function. So which is also called as jump discontinuity points in fx, isn't it? So these are discontinuity points in fx of x, so simple values. This I just want to show you here why the probability of a continuous distribution function at a particular instant is equal to 0. So I told you in the first slide about in the continuous function p of x is equal to xi, that means taking a certain value in continuous distribution function, why it is equal to 0? It is nothing but it is equal to f of xi minus xi minus, so which is actually taking the same value. So whatever amplitude you have here you can take this as xi minus, so till xi and xi minus. Okay, similarly in the case of discrete fx of x, only one value, not f of xi. And in discrete we call it as probability mass function. So fx of x in discrete we represent it as px of x. Okay, and in for continuous random variables we call it as density function. For discrete random variables we use the term called probability mass function. And this is a small figure of distribution and density. So this is a distribution function, is always cumulative increasing function, whereas density function you can see this is an area, you can see this is a closed function. Okay, so coming to the properties of probability mass function, the first property says that fx of x is greater than or equal to 0. Sorry, fx of x is actually probability density function. So density function of continuous random variable which is always greater than or equal to 0. And the area under the density function is always equal to 1. So how will you represent that? Minus infinity infinity fx of x dx is equal to 1. And similarly fx of x is piecewise continuous. So this is a continuous function. You can see this is a piecewise function, x1 between x1 to x2. You can see this is an increasing function and again a decreasing function. And probability of x taking the value in between a range a to b will be equal to, in between a to b, if you calculate the integral of fx of density function, then you know the probability of that. So which is actually nothing but fx of b minus fx of a. So if you know the distribution function, or if density function is given, you can just integrate within the limits a and b, then we get the probability density function. So with this we'll stop here. Thank you.